Everybody to our third session of our community day.
One here, we can change the layout.
Okay. So we have Hansen Stu here. He is a historian and sociologist of technology and curator of the Computer History Museum Software Center. He works at the intersection of the history of personal computing, graphical user interface, object-oriented programming, and software engineering. Hansen received his PhD in Science and Technology Studies from Cornell University in 2015 with a dissertation entitled The Apps Myth, Community, Identity, Effect, Ideology Among Cocoa Developers from Next to iPhone. Previously, he worked at Apple from 1999 to 2005. He also received his Bachelor of Science degree from Electrical Engineering and Computer Science from UC Berkeley in 1990, and his Master's of Arts in History from the State University of New York, Stony Brook in 2007. Welcome, Hansen. We're so fortunate to have you.
Thank you. I will share my screen now. Can you all see?
Yep.
There you go. Okay. Thank you for that wonderful introduction. You already introduced me, so I'm going to skip this part. So the Computer History Museum, just for a little bit of introduction, our mission is decoding technology, its computing past, digital present, and future impact on humanity, and to preserve and present for posterity the artifacts and stories of the information age. So we're located in Mountain View, just off of 101 and the Shoreline exits. So the same exit that you go to if you were visiting the Googleplex, we're right off of the freeway. We are a nonprofit. We have a 4-decade history. We're home to the world's largest collecting of computing artifacts, with over 75,000 physical artifacts and 150,000 items of code and recorded media. This includes hardware, software, audio recordings, video, photos, documents, etc. So we have several exhibits. We have educational programs, our CHM live speaker series, and we also offer archives for researchers to come to do research in. The Computer History Museum itself was founded originally as the Digital Museum by Digital Equipment Corporation in 1979. So it was originally a corporate museum, but then they spun it out into an actual museum. It became the Computer Museum, TCM, at Museum Wharf in Boston in the 80s. And then it formally moved out here in the 90s and became the Computer History Museum in 2000. And the building that we're currently in was purchased from Silicon Graphics in 2002 during the .com bubble burst. And our permanent exhibit, Revolution, the first 2,000 years of computing, that opened in 2011. And our most recent exhibit, permanent exhibit, Make Software Change the World, opened in 2017. Okay, so today I'm going to talk about sort of the history of going from non-interactive computing to interactive computing. And so back in the early days of computing, the 50s and 60s, the so-called mainframe era, most computers worked with punch cards, and in sort of a workflow called batch processing. So what most people would do is, if they had like a program or something else that they needed to run on, some job they need to run on the computer, they would have the program typed up by a key punch operator, who is often a woman, and then that would give them a stack of punch cards, and then they would take that stack of punch cards and then give them to a computer operator. And the operators basically separated the users from the computer. So the end user didn't have any direct access to the computer itself. And so the operators, what they would do is they would take each person's stack of cards, each individual job, and they would put them all together into a single batch and submit that to the computer. And so the computer would run a whole bunch of different jobs in quick succession, one after the other. And this maximized the amount of time the computer was actually doing useful work. And in the mainframe era, when computers cost around $1 million, this was the most efficient way to get the most use out of that computer. So it really optimized for the computer time, because that was more expensive, and it did not optimize for the time of the end user, because as you might imagine, the turnaround time for the end user would often be a full day, right? So you would submit your cards to the operator, and then you wouldn't get your results in the form of a printout until maybe the next day. And so if you're writing a program and maybe you made a mistake, there was a typo, you wouldn't know that you made a mistake for a full day. So this isn't a very efficient way for the user to use a computer. So this is very much an institutional centered form of using computers, and very much focused on the business world. So, however, there were interactive computers in this era. They just weren't widely used. So the first computer that operated in real time was the Whirlwind, and that was developed at MIT during World War II. It didn't come online until after World War II, but it was developed initially during the war. Originally for the purpose of operating a flight simulator. However, it was later repurposed to be the prototype for the nation's nuclear defense system, which was called SAGE, Semi-Automatic Ground Environment. And so the Whirlwind became the prototype for a computer that IBM later was contracted to build for the military. And so the SAGE system was connected to radar consoles. And so airmen in the Air Force would be sitting in front of this console and tracking anything that would appear on the radar. And if there was something that, a signal that seemed like it didn't belong, they would be able to use one of the first pointing devices called a light gun, and that pointed at the radar screen, and that would enter in the coordinates into the computer. So, of course, if you're trying to protect the country against a nuclear attack, of course, you have to be able to react in real time, right? And this ability to interact with a screen and with a pointing device, this was really the first kind of interactive sort of interface for a computer. And so later machines at MIT were followed from the Whirlwind. So a series of machines, the TX0 and the TX2, were later built. Basically, initially transistorized versions of the Whirlwind. And these were provided to MIT students, and provided a platform for subsequent innovations in interactive computing. Probably one of the most important of which was a thesis by Ivan Sutherland called Sketchpad, which was created in 1963 on the TX2. And this was the first graphics program. So if you see in the picture here, that's Ivan Sutherland, and he is basically manipulating a pointing device to draw geometric shapes on the screen there, using his Sketchpad program. So Sketchpad is kind of the granddaddy of graphics programs in the history of computer graphics. So the TX series of computers were led by Wesley Clark, who later on went on to build another machine called the Link, which was specifically focused on biomedical research. So this line of development of computers would eventually lead to the mini computer industry. So mini computers, as opposed to mainframes, were smaller, cheaper, and simpler to use, and also they were typically interactive and had real-time control. They were to be used by a single person or by a small department rather than an entire institution, and they were typically dedicated to one task at a time. So Ken Olsen, who had been an engineer at MIT's Lincoln Labs, had worked on the TX2, and in 1959 he decided to start Digital Equipment Corporation with Harlan Anderson, another MIT colleague, and they avoided the word computer in their name because they didn't want to be competing directly with IBM, which was the dominant player in computers at the time. So originally they only sold circuit modules, but in 1961, a DEC engineer named Ben Gurley used the modules to create digital's first computer, the PDP-1. Or program data processor, which was based on the TX0 and TX2 designs. So like the earlier machines at MIT, the PDP-1 was interactive. You could type on a typewriter console and get real-time response on the attached printer. And you can see here the PDP-1 also had an optional CRT display that was similar to that radar display that was used on the original Whirlwind. One of the most interesting applications that was created on the PDP-1 was what many consider to be the first interactive computer game by Steve Russell and a number of other programmers and hackers at MIT. So they were actually students at MIT, and they created this the Space War game. And so in this game, you can control two spaceships that are drawn on the screen, and the game simulated real-time physics. So there was a sun that had a gravitational pull, and so you move around each other and around the sun, and you can fire torpedoes at each other. And so Space War was emblematic of this hacker culture that surrounded MIT's computer labs, and it eventually became the topic of a famous Rolling Stone article. So DEC really created this market for mini computers, for cheap real-time computers. And so, initially, by cheap, initially they were in the $100,000 range, but that was still cheaper than the mainframe, which would cost 10 times as much. And mainframes were typically leased, whereas mini computers were cheap enough that you would just buy one outright for your own department. So one of the best-selling mini computers was DEC's PDP-8 computer, and it was one of their best-selling computers. It sold over 10,000 units in 25 years, and that spurred a number of other companies to enter this market. One of them was Data General, and it was started by Ed DeCastro, who was the DEC engineer who had designed the PDP-8. And so he wanted DEC to make a 16-bit mini computer. The PDP-8 was only a 12-bit computer, but he wasn't able to convince them. And so he came out and competed with them with the 16-bit Nova in 1968. And the Nova really set a record for price because it it sold for less than $10,000. So that was a new low water mark for price. And so DEC eventually responded with their own 16-bit mini computer, the PDP-11, in 1970. And the PDP-11s really became fixtures in a lot of university departments. And it was also used at Bell Labs. And one of the most interesting or most important things that were developed on the PDP-11 was the Unix operating system was developed at Bell Labs. And the Unix operating system undergirds pretty much all of our computing infrastructure today in one form or another. So mini computers were one way of getting interactivity. Another way of getting interactivity was to actually take an existing mainframe and to split it up among multiple users. So this was called time sharing. Sort of to give a little context of how this started, during the 60s, the economics of computing, this is before Moore's law. So the economics of computing at the time seemed to indicate that it was more economical to build larger computers rather to build a lot of smaller, cheaper computers. And so this is proposed in 1950 by Herb Grosch, a computer scientist. And so he proposed this thing known as Grosch's law that stated that the performance of a computer grew exponentially in comparison to its cost. So that meant that you would really get the best performance by building a bigger computer. So it was during this era that the idea of that most people thought that it would be better to take bigger computers and to share them among multiple people. And so this vision was pursued particularly by J.C.R. Licklider, who you see in the picture there. So Licklider was a psychoacoustic researcher, and he had helped establish MIT's Lincoln Lab, and he had worked on the Sage, and so he was familiar with the TX0 and the TX2 computers. And so he was convinced, by that experience that all computers should be interactive. That really interactivity was a key feature for computing in the future. And so in 1960, he wrote a paper called Man-Computer Symbiosis, where he argued that humans would be tightly coupled in a relationship with computers. And this coupling would amplify our intelligence. And so, of course, interacting in real time with a computer was key to this vision. And so in 1962, he accepted a position as the head of ARPA's Information Processing Techniques Office. So ARPA, of course, was founded after Sputnik to be, so it's the Advanced Research Projects Agency. It's, the area where the government funds advanced research on technologies that could have military applications. And of course, computing was one of those areas. So the IPTO office was the office that focused on funding computing technologies. So as the head of that office, Licklider was able to use his contacts at MIT and other major universities. And because he had been part of that community, he essentially knew where the professors working on the most interesting research topics were. So he was able to basically fund a number of different universities to be centers of excellence, focusing on particular topics. So among the different topics that the ARPA IPTO office funded were artificial intelligence, graphics, networking and time sharing. And so, time sharing was particularly important to an AI researcher, one of the fathers of AI, John Mccarthy, who started off at MIT and later went to Stanford, because a lot of AI programming was done in a language called Lisp, and the way that people worked in Lisp was in real time. So you would type something in the Lisp interpreter, and you would get a result in real time. And so having a time shared access to a computer was critical for this. So the way the time sharing works is that you take an existing computer, and then it has, it's doing work. The CPU is doing work, and instead of just having the computer devote its entire time to a single job, you can have it switch off between different programs or different jobs. And so that initial capability is called multi-programming. But then you can add on top of that, you can have it switch between the jobs of different users. And so every, say 100 milliseconds, it switches from one user to another one. And since computers operate much faster than people do, if you switch between users fast enough, you can make it appear as if each individual user has direct, complete control over the machine. And the way that the users would actually interact with these computers was remotely. So what they would do is they had a terminal, and the terminal would be connected through a phone line, and so they would be talking over the phone line to a large mainframe running a time-sharing operating system somewhere else. So this would essentially be like, an online experience, right? So this experience sort of initiated the idea that computers could be a utility. And so in a number of companies were later founded in the late 60s, early 70s, that would make a business of selling computer time to customers, primarily business customers. And so, one of these was a company called Timeshare, which was actually located in Cupertino. And Timeshare was one of the biggest players in this space. Another company that is not often thought about in this space was actually CompuServe. So CompuServe originally started selling time in this time shared way as well, and it was mostly a business focused company initially, and it was only the later sort of consumer online experience that originally came about because they were trying to figure out, well, our computers are running at night as well, and most of our business users aren't using the computer at night. So how do we actually make money with our computers in their off time? And so they started to sell computer time to consumers on an individual basis, around in the 1980s. So that's sort of how that started. So as you can see, the experience of using a time shared system is you're already interacting with the computer remotely with a terminal, and initially these were teletype terminals. So these were essentially like a typewriter with a printer. Over time, that gradually gave way to what are called glass terminals or CRT based terminals. So more like a computer screen. So the experience would be more like what you would see later on in the PC era. And because you were all sharing the same computer, you could actually leave messages for other users on that same host computer. And so the first email was developed on time-sharing systems as simply a way for you to just leave a message, and then another user on that same computer could then see that message when they logged in. Of course, this only worked if you were on the same computer. If you were using your terminal to connect remotely to the same computer. The different computers, however, could not yet talk to each other. But once you had the experience of time sharing, it became easy to imagine this same experience, but across multiple computers. And so this was exactly what happened with the directors of the computing office at ARPA. So I think there's a particular story where I believe it was Bob Taylor at the time who succeeded Licklider as the head of the IPTO office. And as the head of that office, he had multiple terminals in his office connected to all the different computers at the different universities that they had funded. So he had that one computer connected to one terminal connected to the computer at MIT, another one connected to Stanford, another one to UCLA, another one to Utah. And he thought, why do I have all into any one of these computers and then also connect to any of the other ones through any of the other computers? And so the idea of connecting them together through a network came about. And so, again, as I mentioned earlier, ARPA really heavily funded networking research. And so the Arpanet was what resulted from this. And so that came online in 1969. Later on, the Arpanet would become the backbone of the internet. But at this early stage, it was still one network. It was still a single network around the country. So next, I'm going to talk about one of the nodes that was on that Arpanet was really important in its own right, and that was the online system, or NLS, at SRI, or Stanford Research Institute, and that was created by a team led by Doug Engelbart. So Engelbart had been influenced by a paper written by Vannevar Bush in 1945 in The Atlantic. And that paper described a device called the MEMX, which was a desk that had microfilm inside and that would bring up knowledge. It basically be looking up knowledge for the user. So like a personal library, and the user could follow cross references in the text. And for Bush, that really spurred the idea of hypertext. And so Engelbart and Ted Nelson both independently came upon the idea of hypertext. And so that would be implemented in the online system. The online system was this interactive computer system that also incorporated a bunch of multimedia elements. So you could mix text and graphics and video all at the same time. And it was a collaborative environment. So multiple users could interact with the same thing at the same time. And it also required a pointing device. And so Engelbart had done a number of experiments with various pointing devices, including light pens. But eventually he decided that he needed to invent a new pointing device for his system. And so he and Bill English created the mouse for this innovative computer system. And so this was really demoed for the first time at the joint Fall Computer Conference in 1968. And so it was known as the mother of all demos. So it made a really big impact at the time. As I said before, the NLS was also an important node on the Arpanet. It was the center for it was a network information center. So it actually held information about all the other nodes and all the other users. So this was based on the NLS was based on an SDS 940 mini computer. I'll also mention there was another important system in the late 60s, early 70s called Plato that was developed at the University of Urbana-Champaign. So that also was important for developing graphical graphics, sort of an online network experience, and it had the first flat screen display. It had a plasma display, and so the Plato system was developed primarily for education. So these sorts of influences were important influences on the work that occurred at Xerox PARC in the 70s. So in 1969, Xerox decided to enter the computer business by buying a mini computer maker, Scientific Data Systems, which made a number of the systems that were being used by these time-sharing companies, the SDS 940. And so in 1968, Peter McCulloch became CEO of Xerox, and he wanted to orient the company around what he called the architecture of information. And so the idea was that Xerox wasn't just a copier company, it was an information company. And so he wanted Xerox to be a player in the future when information wasn't just on pieces of paper. So he eventually hired. So as part of creating entering the computer business, the Xerox decided to create a research center. PARC, which stands for the Palo Alto Research Center. And to help create that center, they hired Bob Taylor, who was the former director of the ARPA IPTO office. And so Bob Taylor, because he had been part of ARPA, he knew all of the major players, all of the important researchers in the ARPA community. So he hired a number of different people from different organizations. In particular, one group, which was sort of becoming disaffected by the research that Engelbart was doing, decided to leave Engelbart's lab at SRI and join Xerox PARC. And then there was another group that was hired. So Butler Lamson, Chuck Thacker, and a number of others. They had been part of a team at Berkeley that had developed a time-sharing operating system, and had modified the SDS 930 into the SDS 940. So they had actually created the system that SDS later used to create its time-sharing operating system, and that Timeshare later used to run its business. And so they had formed their own company, Berkeley Computer Company, but that failed. And so right after that failed, they all came en masse to Xerox PARC. And then another key hire was a researcher named Alan Kay. So Alan Kay had done his PhD at the University of Utah. And Utah was another one of the ARPA centers of excellence. And in particular, it was the graphics center. So Utah, has been a major center for computer graphics. One of the co-founders of Pixar, Ed Catmull, is an alumnus of Utah. One of the co-founders of Adobe, John Warnock, is an alumnus of Utah. So Alan Kay had been doing research on computing for education, and he had already thought about computers shrinking down to the point where they might be used by an individual person. And in 1968, he had actually created a mock-up for what he envisioned would eventually be a tablet computer. So Alan had visited the University of Illinois. He had seen the first flat screen display. And once he saw that, he imagined that some point in the future, it would be possible to create a tablet computer. And he imagined that this would be used by children, and that children would be able to learn on these machines and be able to use these computers to simulate aspects of the real world. And so that led to the creation of the Xerox Alto at Park. So the Alto was created by a team led by Chuck Thacker and Butler Lamson, but it was spurred by Alan Kay's vision for computers that would be used by an individual person, by essentially a personal computer. So this was the first computer with a bitmap graphics display, which meant that, unlike earlier displays, which essentially are like a radar screen, where you have like a light drawn on a black screen, and you can direct that light in different to draw different kinds of shapes based on various equations and such. But with a bitmap display, what you can do is you can have essentially black text on a white screen. And this is made possible by what the bitmap is actually a section in memory where you have, and you basically represent the screen as individual pixels. And this is what we all use today, but at the time, this was a new thing. So each pixel could be either white or black, and you would, and the bitmap in memory would tell you whether the part of the screen, the pixel on the screen, was white or black. And so the electron gun essentially just draws, white or black depending on what the bitmap is telling you. This was only possible in the early 70s because of the use of new semiconductor memories. So the Intel had just recently invented the dynamic RAM, and so that became available, and so that made it possible to have a large enough amount of memory to have a bitmap display. And so this was a research computer. So actually, almost half of the amount of memory of the Alto computer was used for that bitmap display. Of course, I mentioned earlier that a number of researchers had come from SRI, so they brought with them the mouse, and along with that came a number of other innovations. So Alan Kay and his team, which was focused on creating a system for education, created Smalltalk. Which so Smalltalk is both a programming language. It's an object, one of the first object-oriented programming languages, but Smalltalk is also a user environment. You can think of it as an OS today. It takes over your entire environment, and it had what we call the first modern graphical user interface. So it had overlapping windows. Which was one of the first times that any computer had that, and it had pop-up menus. And this would become pretty important because in 1979, a team from Apple led by Steve Jobs came to Xerox PARC, and they were given several demos of the Alto running Smalltalk. And so it was this set of demos that led to the graphical user interface transferring from PARC over to Apple and becoming the interface for the Apple Lisa and the Mac, which we'll see later. A number of other things were invented at PARC. The first word processor that worked in what we call WYSIWYG, or what you see is what you get mode. So that meant that like today with, if you're working with Microsoft Word, you can have multiple fonts, multiple styles, and then what you see on the screen is what you get printed on the paper. Prior to that, if you wanted to define fonts or styles, that was all done in a type of in code, sort of like like think of it as like you're writing in HTML, right? So when you're writing in HTML, you don't see what you get out on the screen. You're just writing in code, and so that's not as efficient a way to work for most non-computer users. Bravo was developed by Charles Simonyi and Butler Lamson at Park, and Charles Simonyi would later go on to Microsoft and to create Microsoft Word. So there's a direct lineage there. The Alto was also not meant to be a single, an individual computer, but it was also meant to be on a network. And the Ethernet networking technology, local area networking technology, was invented by Bob Metcalf and Dave Boggs at Park and implemented on the Alto. And so all the Altos were networked with each other. And you could actually designate some Altos to be servers. So like a file server or a print server, etc. And so this was also the origin of what we now call client server computing. And of course, if printing was also important. Of course, Xerox was in the copier business, and the first laser printer was invented at Park by Gary Starkweather. And a laser printer is essentially like a copier, except that instead of the image coming from an existing piece of paper, the image is generated just out of mathematics from the computer. And so you can do this in various different ways. But one of the more important things that you would need to do if you wanted to generate images and especially text for a laser printer is you want those images and that text to look smooth regardless of the resolution of whether it's the printer or whether it's the screen, right? The screen has a much lower resolution than a laser printer, but you still want them to look relatively similar. And so you want to be able to describe the things that you're drawing in a resolution independent way. And so researchers John Warnock and Chuck Geschke, who are at Park, developed what is called the page description language called Interpress that was able to do this. However, they weren't able to get Park interested in bringing this to market fast enough for their taste. So they left Park and decided to found their own company, Adobe. And so they took that idea of Interpress and they created a new version called Postscript. And Postscript is the basis of PDF today, which we use everywhere. So I mentioned earlier Smalltalk. Smalltalk, here's an example of what Smalltalk actually looked like. So Smalltalk was developed. So the idea, Alan Kay was the leader of the team, and he was sort of the visionary behind it. Dan Ingalls was the lead implementer, and Adele Goldberg was a key important person in actually moving forward the educational component of Smalltalk. So Smalltalk was developed with children in mind for pedagogical purposes. So Goldberg actually ran classrooms at a local school to actually, with Altos running Smalltalk, to actually see how children would actually be able to use Smalltalk to design their own programs, to work with graphics, music, multimedia, etc. And Smalltalk is really interesting and important. This is actually the 50th anniversary of Smalltalk. So later this year, we're going to have at the museum a celebration, an event celebrating the 50th anniversary of Smalltalk. And as I mentioned earlier, the graphical user interface, the modern interface that we all sort of see, sort of traces its lineage back to Smalltalk. So with the windows and menus and mouse, all being manipulated by a mouse, that all came from Smalltalk. Smalltalk was also an object-oriented programming language. So, influenced most of the languages that we use today, including Python, Ruby, JavaScript, Java, etc. And it also had an integrated development environment. So it was actually a live programming experience. So what that meant was you actually had control over the entire system, which meant that if you didn't like the way something worked, you could actually change it in the code and it would apply right then and there. So one of the examples that they did at one of the demos that they did at Park was, so if you look at the way that the text highlighting is done, it's basically, instead of white on black, it just changes it to, it changes it from black on white to white on black. But if you don't like that behavior, you can actually change it to instead draw an outline, a box around the text instead of inverting it. And you can just change that and then it'll apply immediately. And so this was actually one of the demos that Dan Ingalls did for Steve Jobs in his famous visit. So as I mentioned, that famous visit by Steve Jobs led to the graphical user interface coming over to Apple. And in addition to just that visit, a number of Park employees eventually decided that Park, just wasn't really in the position to commercialize this technology quickly enough. And so a number of them left Xerox and joined Apple. So Larry Tesler, Bob Belleville, and many others. And so in 1979, the Lisa project was started. And also another project, the Macintosh project, also started. And so initially Steve Jobs was heavily involved with the Lisa project, and so the visit to Park was primarily for the Lisa project. And then in 1980 there was a reorganization, and so Steve Jobs was no longer in charge of the Lisa, and so he had to find a new project. So he eventually found this other project that Jeff Raskin had created called the Macintosh, which was a small appliance-like computer. And so he joined that project, and he basically took over that project from Jeff Raskin, and he turned the Macintosh into sort of a mini Lisa, a smaller version of the Lisa. So Apple released the Lisa in 1983, and it was like a $10,000 machine. So it was a very expensive, expensive machine. And because it was so expensive, it really didn't do very well. But the Macintosh was already being developed, and it would come out at a quarter of the price of the Lisa at $2,500 in 1984. And so the Macintosh was the first successful personal computer with a graphical user interface. But it only became successful after 1985, when a new killer application became available for the Macintosh, and that was desktop publishing. So desktop publishing was essentially allowed you to create your own newsletters and other sort of publications on your computer at home and print it at home. So in combination with Apple's first laser printer, the LaserWriter, which was developed in partnership with Adobe because it had Adobe Postscript built into it. And then there was a new program by a company named Aldus called Pagemaker. And Pagemaker would allow you to actually take text and graphics and be able to compose your own publications. And so this really began the desktop publishing revolution. And this is what eventually led Apple to really be a major player in the content creation industry, in which it still is located. So I think we're pretty close on time. So I will stop there and open up for questions. So we have a number of questions from the chat. So one question is, who do you think will be the future of computing? Apple, Google, Amazon, or Microsoft? That's a really tough question to answer. It's really there's really no way to tell whether it will be any of these companies or a new company, right? It's interesting because in the 1960s, IBM was so dominant that it was being investigated for antitrust violations. So it would have been difficult to imagine a world in which IBM was still not the dominant player in the computer industry in the 1960s. And of course, today we have the FANG companies, where we have Apple, Google, Facebook, Amazon, Microsoft, etc. And they're really dominant now. We don't know what new technology is going to come on in the future. Now, there's a number of different things that people are betting on. There's cryptocurrency, there's AR and VR, there's self-driving cars, AI technologies, and it's still not clear to me what is going to be the next big thing, and we don't know if any of the existing companies will control that next big thing, or whether it'll be a startup. I think that one of the interesting things is that these companies kind of have learned from their past, and so whenever an interesting startup has appeared, they've usually been acquired by one of these larger companies, particularly Google and Facebook. So we'll see what comes along. Apple sort of bucked this trend because they were almost left for dead in the late 90s, and then they managed to come back, and then they created the iPhone. So Apple is kind of an exception to the rule, in that it became irrelevant, and then it became relevant again. We have another question: where did Univac fit into this history? So Univac is actually in the earlier stage of this history. So Univac was founded by the two of the engineers who developed the ENIAC. So the ENIAC was a computer at the University of Pennsylvania, and it's the first general purpose programmable electronic computer. And the ENIAC eventually led to the creation of the stored program architecture, or the von Neumann architecture, which all computers use today. The ENIAC itself was not a von Neumann machine, but the successor to the ENIAC was, and it was basically out of the experience of learning from the ENIAC that led to the development of the von Neumann architecture. So Univac was then founded by J. Presper Eckert and John Mockley, the developers of the ENIAC. And Univac was a stored program machine, and so Univac was the first computer, the first commercial computer to be developed and sold in the United States. And so it kind of predates this history that I'm talking about in some ways, because the Univac really was more of this old batch processed punch card story, and the Univac was a really big player in the early 50s, but then IBM entered into the computer business. So IBM had already been selling punch card based machines that were mechanical, that sorted data mechanically, and those machines were used called unit. So that was called unit record equipment. There was nothing electronic in those machines, and so IBM saw that the new computers would eventually obsolete that business, and so they jumped into the computer industry and brought their punch card expertise with them. And so that's why the punch card, the IBM 80 column punch card format predates the computer. It actually came from IBM's earlier business. And IBM quickly took over the computer industry in the 1950s, and to the point where by the 60s, the computer industry was dominated by IBM. So it was known as IBM and the Seven Dwarves. All the other computer companies, including Univac, which was purchased by Remington Rand and Sperry Gyroscope, which was a bunch of mergers. So it was basically owned by Sperry Gyroscope in the 1960s. So Univac sort of lost its lead in the computer industry to IBM. But again, Univac and IBM were initially part of this earlier punch card batch processed way of interacting with the computer, which was not real time. Yeah. So any other questions? Did Sun Microsystems Workstation create anything new? Okay, so that's a good question. So workstations are another class of machine that, if you think about it, workstations really come out of the Alto. Actually, experience with the Alto directly led to the creation of Sun. So Altos, so Park had a program where they actually had Altos installed at a number of different universities. Stanford, of course, being the closest one. A bunch of Altos were at Stanford. And remember, Altos were also all networked together on a local area network. And so the Alto essentially became the prototype for what later became the workstation industry. So the Alto was a prototype for both personal computers and workstations. In a lot of ways, because the Alto was a very powerful machine. It wasn't really, the Alto was a research machine. It wasn't ever created to be sold on the open market. But it was a very powerful machine. And so when Andy Bechtolsheim, who was the founder of Sun, one of the founders of Sun, he was a student at Stanford, and he had experienced the Alto, and so he wanted to create a company, create a computer that would be like the Alto, but would actually be cheaper to produce. And one of the things that was also coming around in the 70s was new microprocessors, right? So the Alto itself didn't use a microprocessor, but microprocessors, by Intel and other companies, were starting to become available. And of course, microprocessors spurred obviously the PC industry, right? With the small computers like the Altair and the Apple II. But there are also other more powerful microprocessors. So the most powerful microprocessor that became available in the late 70s and early 80s was the Motorola 68000. This is the same microprocessor that was used in the Macintosh. But it was also used, it was really powerful because it was a 32-bit processor, much more powerful than the 8-bit processors that are in like the Apple II and the IBM, the original IBM PC. So the early workstation makers like Sun, Sun's big thing was to mainly build a computer with off-the-shelf parts. So they took the Motorola 68000 and they combined it with networking and with cheap parts to make as cheap of a workstation that you could get, and to sell it to the scientific, to the technical market. So this was mainly the same market that mini computers were already in. So mini computers were primarily being used by scientists and other things, and workstations. Now they brought that same experience, but now to your desk, and at a fraction of the cost. And they also used Unix. So they brought that Unix experience that already existed on mini computers, and they brought that to sort of this personal experience. So workstations were also a form of personal computer. They weren't called personal computers, but they were personal because they were a single user machine. So Sun really made a big impact in that industry, and really spurred that industry. So so Sun was a very significant player throughout the 80s. And of course, that eventually, because they were networked, they led to client server computing, and then they became a big important company in the server space. And so when the internet, when the commercial internet came around in the 1990s, and the need for servers became really important, Sun became a big player in that space too. So so there's a direct connection there as well. I don't know if, I think we're proud at time. So
Thank
I
you
don't
so
think we
much,
have time for
Hanson. What a
questions.
wonderful presentation. The history is
Thank you.
great. Thank you.
Thank you.